So in this case, we've got equations that we need to solve for x. So we are given the two equations, solve for x. The first one that we are given seems to be a basic equation. All right, that's 4 to the exponent of x minus 2 to the exponent of x plus 2 is equal to 0. That's working with your exponential equations. All right. I say that if you are given different bases like what we have here, we've got the base of 4 and this is the base of 2. Let us consider the same base. 2 is already in simplest form because it is a prime number. So we have to change 4 to be written in the base of 2. That's 2 to the exponent of 2. A 4 in the base of 2. But remember, it is being raised to the exponent of x. Minus 2 to the exponent of x plus 2 is equal to 0 like this. All right, so let's see what we have here. Remember, an exponent, you can multiply. So that's 2 to the exponent of 2x minus 2 to the exponent of x plus 2, which is equal to 0 like this. That is the condition, which is equal to like that. So if we are to consider, we are having 2 to the exponent of x. 2x. These two, they are different. Let's separate so that you can properly see this, all right? You'll see this, okay? No problem, guys. 2 to the exponent of 2x. Let's leave it like that. Minus, remember addition. Remember I said this addition is just like 2 to the exponent of x times 2 to the exponent of 2. You were multiplying, having the same basis, and you have to add the exponents. So this can be separated that way. There's a 2 to the exponent of 2 there. So that is a 4. So it's 2 to the exponent of x times a 4, which is same as we've got 4 times 2 to the exponent of x. That's equal to 0. All right. This is where you are. There's an interesting part of our question here. Here, the interesting part here. This is 2x. Like I said before, this is x. I said you can separate this in the same simplification of this 2 to the exponent of x. Okay. We are looking into these two. And we need the one that is the least, that is the smallest exponent. So that's 2 to the exponent of x, this one. Remember how it was here. 2 to the exponent of 2 to the exponent of x. These two can be interchanged. These two can be interchanged. So it can be written even this way. It is the same thing here. It is the same thing this one. Remember, it's a multiplication that is happening. So you can write it this way or this way. So as we need where we can properly see these 2 to the exponent of x, this one. So we are going to take this one. So it is going to be 2 to the exponent of x raised to the exponent of 2 minus 4 times 2 to the exponent of x equal to 0 like this. This is the part here that is important to properly see this one. As we can notice that it is no longer a normal equation that we just used to, because it is being raised to the exponent of 2. So it means there we are going to formulate a quadratic equation. We are going to formulate a quadratic equation. But how so? How can we formulate that quadratic equation? we can use as it is because it's already a quadratic equation. We can use as it is, or we can introduce the letter k. That's where we can say let k be this part, which is the same. So k be equal to 2 to the exponent of x. Guys, we are now used to this one. All right, so substitute now this with the k, that is k squared minus 4k here. It is just going to be k minus 4k. It is equal to 0. We introduced something which is not part of our equation. So we are solving for k this time, not x. We are going to solve for x later on. So how can we solve here, guys? This is a normal quadratic. You can factor out k, which is common. So factoring out k squared divided by k, that's a k. Minus 4k divided by k is going to be minus 4. That's equal to 0 like this. All right, so remember from this, one part is supposed to be equal to 0. Either you're talking of the bracket, you're talking of this k, whatever that you have. So k, let it be equal to 0. So k is going to be equal to 0, or this other part, k minus 4, is equal to 0. So if k minus 4 is equal to 0, it means k will be equal to what? A positive 4. Remember, you are solving for k, not part of your equation. The equation is in terms of x. So meaning to say, after having this value of k, we are going to substitute now where we introduced the k here to solve for x now. So if k is equal to 2 to the exponent of x, our k being as 0, are we going to have a solution there? Are we going to have a solution if 0 is equal to 2 to the exponent of x? Is there any number that we can use there? There's no number that you can use to raise that you can raise to the exponent of, let's say to the exponent of any number, then you obtain a 0. It's impossible. So it's actually impossible on this one. What about if k is 4? When k is 4, we are going to have it as 4 is equal to 2 to the exponent of x, where 4 in the base of 2, 2 to the exponent of 2, 2 to the exponent of x. Remember, if the base are the same, you're going to take the exponent. So therefore, x is equal to what? X is equal to 2. If the bases are the same, therefore the exponents will be equal. So this is our solution. X is going to be equal to 2. There, we do not have any solution from this other part. So that's the consideration, guys. So do not forget in exam, guys. Do not here. Most of you leave your answers at this stage. No. The question, what were you solving for in the original place? You are solving for what? For x, not k. We introduced that one just to help us. Okay? It was something that we introduced just to assist us in obtaining the value of x. So don't take that one to be a part of your equation to say, now this is what you're solving. No. All right, let us move on to another part. We are given another equation that will be our equation 2, 3 to the exponent of 2x. All right, 3 to the exponent of 2x plus 1 minus 28 times 3 to the exponent of x is equal to minus 9. Same application just like the previous case. All right, you can take the minus 9 to the other side, 3 to the exponent of 2x plus 1. All right, minus 28 times 3 to the exponent of x. The minus 9 will give us a positive 9. That's equal to 0. All right, let's focus with x. 3 to the exponent of x, 3 to the exponent of 2x. So remember I said when you are adding, it means 3 to the exponent of 2x times 3 to the exponent of 1. So 3 to the exponent of 1, guys, is just 3. So it's 3 times 3 to the exponent of 2x. minus 28 times 3 to the exponent of x plus 9 is equal to 0, guys. Now we are used on this one, guys. 3 to the exponent of x. This is same 3 to the exponent of x there. So we are going to write it as 3 times 3 to the exponent of x raised to the exponent of 2 because of this. Raised to the exponent of 2 minus 28 times 3 to the exponent of x plus a 9 is equal to 0. Thus, a quadratic equation that we have the highest exponent is 2. But for us to solve with these 3 to the exponent of x at the same time, it becomes just complicated. That's why we introduce a constant just to help us, to assist in simplification. So we can use something that is easier for us in the simplification. All right, so in this case, we are going to let k be equal to 3 to the exponent of this part which is common, 3 to the exponent of x. In place of that, we introduce a k. So meaning to say this is going to be 3 times, this part is k. So it is k squared. Remember, there's a square there. Minus 28. This part is represented by what? By k. Minus 28k plus a 9 is equal to 0 like that. This is what we have. See, solving these equations, guys, is now in your hands. Solving later on, it will be in your hands. How are you going to solve this part? Remember your factorization method. Here, factorize it. This is 3k squared, all right? So just write 3 there. 3k squared like that. What we need here is to have 2 brackets. This is what we know. Equal to 0 from your factorization. How are you going to have these 2 brackets, guys? It is in your hands. So I'm going to, first I actually, you see, if you're working with this part of exponents and sets, they work with this part on it, then we're going to have it as equations later on. But you see, those equations, we need them now. So I'm going to upload the videos on equations using the cheat methods of these quadratic equations. So I'm just going to explain this one. I explained it in grade 10 mathematics for those who were watching the videos. So there, it is in your hands from here. How are you going to factorize there? I do not know which method are you going to apply. We just need 2 brackets there. All right. So using the cheat method, guys, this one, there's this method, 3k squared minus 28k plus 9. As we can see, we can't divide by 3. We cannot reduce this one. So using the cheat method is that we take the 3 because the coefficient here is complicating everything, 3. So we are going to multiply the last number by 3. You multiply that by 3. So it is going to be k squared minus 28k plus 9 times. Remember, you multiply by 3. 9 times 3 is what? 27. Since the coefficient of k squared is 1, now here we can see that we have got a 1. We can simply have our 2 brackets with the k and k here. Remember, 1. So it means k and k. Then we focus with what? 27. At least know these basics that we focus with 27 factors of 27, which will add up to minus 28. That's minus 27 and minus 1. Minus 27 and minus 1. You multiply this, it's positive 27. You add these, you get minus 28. So that's minus 27 minus 1. So this is the tricky part of this cheat method. This is the tricky part. You removed the 3 so that you have this one as a 1. You multiplied it there. It was on k squared. So you have to bring back that 3 in place of what? K. But it's no longer k squared because you separate. There's a k here, there's another k there. So you bring it both. Here, you bring a 3. Here, you bring a 3. The 3 that you remove there, you bring it back. Where there's a k, where there's a k. Okay, this is where you are. In a bracket where there is anything common, factor out. If there is anything common in a bracket, factor it out. Like the first bracket, 3 is common. So you factor out the 3 like this. So it's going to be 3 divided by 3, which is remain with k, minus 27 divided by 3 is going to give us negative 9. And this bracket, there is nothing that is common. So it is just going to remain as 3k minus 1 like this. So this is it. The 3 that you factored out is not part of your question. You take it away, this one. This is your answer from these two brackets. You're going to obtain k minus 9, 3k minus 1. Or you can start with 3k minus 1, k minus 9. It's up to you. But this is what you're going to have. K minus 9, 3k minus 1. So all these factorization part, guys, they do not show you in exam to say where was it taken from. It is just the quadratic. Then they show you this, the two brackets. So how to obtain these two brackets? That's why that is why I'm saying it is in your hands. I don't know which method are you going to use, the exact method, whatever that you understand. So there we can solve for k. Minus 9 to the other side gives us a positive. So k is equal to 9. Or on this one, minus 1 to the other side will be a positive 1. Then you have to divide by 3. So k is going to be 1 over 3. All right. So these are the values of k, not x, as we are solving for x. So bring back that part where we introduce that k. So k is equal to 3 to the exponent of x, meaning to say from that here, we are going to introduce, we are going to bring these values in place of what? K, that is 9 is equal to 3 to the exponent of x, or 1 over 3. It is equal to 3 to the exponent of x in place of k. Then we solve for x. All right, so let's consider the first part. 9 in the base of 3, that is 3 to the exponent of 2, is equal to 3 to the exponent of x. So as we can see, the bases are the same. So x will be equal to what? X will be equal to 2. From this part, we have 1 over 3. Remember, 1 over 3 is same as 3 to the exponent of negative 1. 3 to the exponent of x. The bases are the same. So x is equal to negative 1. So this is what we are going to have at the end. The possible values of x that we are going to obtain from that simplification is going to be 2, or another x is going to be equivalent to negative 1. So that's how these questions will be given. You introduce the k. This part, it is something that we introduce. So we are supposed to get rid of that so that we solve exactly for the x that you're being given. So that's how these questions are given. Let's just try to revise as many questions as we can. As we can see, these questions can be given differently. And the factorization, this part of your factorization is supposed to be in your hands, how to factorize these and solving later on. So let's revise, guys, as much as we can till we meet again.